everyone, I'm Laura. I'm an exhibit designer at the KU Natural History Museum. For National Fossil Day, I'm going to give you a sneak peek at some of the design work that went into an exhibit we are currently installing, the KU Paleontology UP CLOSE exhibit. This exhibit focuses on some of the Biodiversity Institute's paleontology research and shows unique fossils and their stories. I'm going to share some of the design work that went into making the invert and paleobotany fossils come to life through interpretation. Fossils in this exhibit span many hundreds of millions of years. Let's start 500 million years ago in the Cambrian time period. As you may know, most of North America was underwater throughout the Cambrian period. Imagine a shallow water marine habitat. Here are images of 3 fossils from this time. We have soft-bodied filter feeders and a snail-like mollusk. My background is in the fine arts, and by no means am I a paleontologist. So this information I get from the curators and collection managers at the KU Biodiversity Institute really informs how I interpret fossil information. Here are illustration sequences that show how I outlined these fossils and then use that evidence to influence a hypothetical illustration. We can never really know exactly what these animals looked like, but with research and, if possible, referencing living relatives, we can provide an interpretation. As you can see from the drawing sequences, the soft tissue preservation in the fossils really inform the illustrations. The soft-bodied filter feeders anchored themselves into loose sediment and would filter water to get food. You can identify their digestive tracts in these fossils and see the elongated slug-like body with the shell and the snail-like mollusk. Now let's journey back 95 million years to the Cretaceous period, when Kansas was covered by a shallow sea. Uncovered in the Niobrara chalk is this ammonite and lower jaw plates of another ammonite species. Ammonites are an extinct group of mollusks with a distinctive coiled shell and flexible arms that extend from the head. To help illustrate this animal, I looked to living relatives like octopus, squid, and cuttlefish, and then I studied the contours of the fossil shell. Another way the exhibits department brings fossils closer to the viewer for examination is by creating replica casts, like this cast of the lower jaw of an ammonite. My colleague and fellow exhibit designer, Greg, created a mold of the fossil jaw plate. Looks like this. And then he poured casting material into it to make this cast. From there, I went ahead and painted it to make it look like the actual fossil. Also from the Cretaceous period is this ground-dwelling spider. This fossil is the earliest record of this spider family. It too has living relatives that help inform my illustration. With CT scanning, we are able to provide a large 3D model of a very tiny fossil. This painted cast of the ground-dwelling fossil spider was produced by 3D printing the surface mesh data of the spider at 20 times the original size. From there, Gray created a mold of the 3D print, cast it, and I painted it. It's so cool that we are able to provide this enlarged representation from such a tiny fossil. Here is a final look at these invert illustrations and how they are presented in our new exhibit. Lastly, we'll take a look at the forests of Antarctica during the Permian and Triassic time periods. Permian forests were dominated by similar-looking glossopterid species. Millions of years later, during the Triassic, new groups of seed-bearing plants evolved with a greater diversity in appearance. To highlight this shift, I created a landscape for the exhibit that illustrates the change in climate and the increase of plant diversity in the Triassic. Again, we don't know exactly how these trees looked, but by studying the fossils, you get a pretty clear view of the fronds. The fossil plant specimens, as well as drawings by scientific illustrators and researchers, help inform the landscape I created. This illustration sequence shows how the trees and elements of the landscape were completed in different layers and then digitally painted to create the shadows and lighting. I hope that you enjoyed taking a look at some of the illustration and design work that went into creating KU Paleontology UP CLOSE. We are working on installing this exhibit right now, and we look forward to the day when folks can come to the museum and enjoy it. Thanks, everyone.